Okay, so today we're doing exponential functions. The equation, and I need everybody to write it down, is y equals a parentheses b close parentheses to the power of x. Linears, you've seen linears like this before, y equals mx plus b. And you've seen quadratics before, y equals ax squared plus bx plus c. The difference is that this one doesn't have an exponent. That's a 1. This one has an exponent of 2. This one has the exponent as your x. So that's the difference. Okay? Now, when you look at this, if the number inside right there, that b, is greater than 1, meaning it's a 2 or a 3 or a 4 or a 5, that's going to be an exponential. Write this down. Growth. Okay? Which means it is increasing. Now, if the b, again, that number inside, is smaller than 1, meaning it's a fraction or like 0.25 or 0.50 or 0.75, then it's going to be an exponential decay. Which means it's decreasing. Okay, and some of you have seen these functions before, these graphs. This is what an exponential growth looks like. It just goes up. And this is what an exponential decay looks like. It goes down. Okay? Now, there's one more thing that I have to teach you about exponentials, and that's called the asymptote. Okay? And the asymptote is an imaginary line like this. Look. That's on the growth, and then on the decay, the same thing. So that's like an imaginary line. It's like a force field. I want you to write it right here. Think of a force field. And a force field is something that you can never touch or cross. Okay? So we're going to say it's an imaginary line. Where the function can never touch or cross. Okay? So, if you're not done writing this down, I need you to pause. I'm going to do 3 examples with you, and then you're going to do 3 examples by yourself. So we're going to go ahead and do problem number 1 together. I need everybody to put this function in Desmos because we need to graph it. So in Desmos, y equals 2 to the power of x. Y equals 2. And this is the button that we're going to use to the power of. Okay? And then type the x up on top. So then it does it for you. What's the first thing you see? The y-intercept. Okay, so I need you to draw the y-intercept, and I need you to write it on your paper for problem number 1. Draw it and write it. The y-intercept is at 0, 1. So right here and right here, 0, 1. Now when you draw it, it looks something like this. Right? So I need you to just sketch it. For sure you have to have your y-intercept on there, and I need you to sketch it and tell me, is that a growth or a decay? Growth, because it's increasing from left to right and it's going up, right? So we're going to circle growth. So really quickly, we found 2 things just by putting it in Desmos. What else? Remember the force field that we were talking about, the asymptote? If I was to draw it here, what number would it cross? If I was to draw the asymptote, like a force field, if I was to draw it, what number would it cross? 1, but then it touches it. It can't be at 1 because then it's going to touch it. Remember I told you you cannot touch it and it cannot cross it. 0. So everybody draw your asymptote. And if you don't believe me, let's go check in Desmos. And what I'm going to do is I'm just going to start zooming in. And you're going to notice, because right now, look, it looks like it touches 0, right? But if I zoom in, the more I zoom in, the more I notice that it never really touches at 0. You see? It's not touching the 0, the x-axis. It just gets really, really, really close, right? But it never touches it. That's what an asymptote does. So I'm going to hit the house again so that it can go back to normal. And I'm going to put that my asymptote is at y equals 0. Okay, I drew it for you, the blue line. It's an imaginary line. And it's at y equals 0 because it crosses the y-axis at 0. Okay? And now the domain and the range. Remember, domain, you start it like this, and it goes from left to right. So what is the leftmost point? The leftmost point. Let me go look at my graph. When does it end on the left? Never, right? It's going to keep going forever and ever and ever. It's negative infinity. And then to the right. Okay, when does it end on the right? Infinity. I mean, it's going really, really slow, right? But it's going to keep going forever and ever to the left, to the right. So we're going to put that it's going from negative infinity to positive infinity, which means all real numbers. All real numbers. Okay? The range, that's the one that goes from the lowest point to the highest point. So what's the lowest that it gets to? 0. That's that asymptote, right? So we're going to start it like this, and we're going to say that it goes to 0. But does it ever touch 0? No, so we're not going to have a line right here. Remember I told you it's like a force field and never touches it. And then what is the highest that it goes to? Infinity. It goes all the way up and up and up forever and ever and ever, so it's infinity. Now, I don't need the infinity part. I only need the ones with the numbers. And then you flip the whole thing so it becomes y greater than 0. That means this exponential function is all the numbers greater than 0, not equal to 0. Okay? Let's go ahead and type the next one in the calculator. And you can pause the video and see how many you can figure out without my help. So type y equals parentheses 1/4 close parentheses to the power of x. Okay, so problem number 2, you should have already put it in the calculator. Y equals parentheses 1/4, that means 1 divided by 4, close parentheses. Hold on. Click it to the side, close parentheses to the power of x. Okay, clearly this is a decay. It's going from left to right and it's decreasing. And you can also see the y-intercept, which is at 0, 1. So we're going to go ahead and write that and draw that on here. That's my y-intercept, and it's decreasing. But it gets really, really close to what number? 0. It gets really, really close to 0, right? And again, we can zoom in if you don't believe me. It gets really, really close to 0, but it never touches it. Okay? Again, you need to zoom in if you cannot see it. So I'm gonna draw my asymptote right here. Again, it's a decay. The y-intercept is at 0, 1. And my asymptote is at y equals 0. Y equals 0. Okay, what about my domain? What is the leftmost point to the rightmost point? Infinity, because it's going to go to the left forever and ever, and it's going to go to the right forever and ever, so that's all real numbers. What about the range? What is the lowest that it goes to? 0, that's the asymptote. What is the highest that it goes to? Infinity. So we're going to write it like this. 0 all the way to infinity. And we're going to get rid of the infinity side and just say y greater than 0. Okay? I want you to do the same thing with problem number 3. If you haven't, I want you to pause the video, do it first, see how many you get right when I do it with you. So you're going to put this equation in Desmos and figure out those answers. Okay, so this last one, we type it in Desmos, 3 to the power of x minus 1. So y equals 3 to the power of x. Make sure you bring it back down, minus 1. And it gives it to you right here. The y-intercept is at 0. So the asymptote is not at 0. Okay, it cannot touch it. So what is it getting closest and closest to? It's getting closer and closer, you see, to negative 1. So my asymptote is negative 1. And here's another way that you can figure it out. I don't know if you guys noticed, but that number at the end is your asymptote. And if there is no number at the end, like on problem 1 and 2, we didn't have a number. Problem 1 and 2, see right here? That's my asymptote, which was 0. This is my asymptote, 0. So whatever number they add or subtract at the end, that is your asymptote. So right here, I'm going to draw it. My y-intercept is at 0, 0. And it gets really, really close to 1. It is a growth. Oops, 0, 0. And the asymptote's y equals is getting really close to negative 1. Okay? So here it is. Also, remember I told you that number inside the parentheses tells you if it's a growth or a decay. This one is a growth because it's bigger than 1. Problem 1 and 2, let's go back and look at them. Problem 1, that was bigger than 1. That's why it's a growth. And this number is smaller than 1. That's why it was a decay. Okay, so that number inside tells you if it's a growth or a decay. The number on the outside that they add or subtract, that's your asymptote. I don't know if you guys noticed, but the domain for all exponential functions will go forever and ever to infinity. That's why domain is always all real numbers for exponential functions. Okay? And then the range usually starts at the asymptote. So what's the lowest that it goes to? Negative 1, we said that it goes to negative 1. And the highest is infinity. So we can get rid of the infinity part and just say y greater than negative 1. Okay, make sure that you finish the other 3. Whatever you don't finish is homework. And I want to see it tomorrow.